Somewhere beneath the Kola Peninsula in the Russian Arctic, engineers pulled up a rock core containing fossils older than complex life itself, and traces of water flowing where every textbook said water simply could not exist. That hole is the deepest thing humanity has ever dug, and it is thinner than the plate you probably ate dinner on last night. That hole reaches over 12,000 meters straight down, and it is only 23 centimeters wide. With all that depth, all that money, all those decades of engineering, humanity has still only covered about 1/5 of 1% of the distance to the center of the Earth, because past a certain point, the planet simply stops cooperating. Temperatures climb past 180 degrees Celsius, steel starts twisting like rubber, solid rock begins behaving like melted wax, and according to the engineers who lived through it, that was only the beginning of the strangeness down there. We have sent robots to comets moving tens of thousands of kilometers an hour. We have mapped the surface of Mars down to the boulder. And yet, straight down, beneath our own feet, we have barely scratched the first layer of paint on a house we've lived in our whole lives. Today we're going as deep as humans have ever gone, through the strangest borehole on Earth, into the middle of the ocean floor, and inside the largest craters ever excavated by hand and machine. We'll find out exactly why the mantle of this planet remains, in large part, forbidden territory for our entire species. And at the very end, a discovery from 2023 that almost nobody knows about quietly rewrote 66 years of failure into a single, real success. Stay until then, because it changes the ending of this whole story. On paper, this should be simple. More power, better drills, more money, more time. Eventually, you punch through anything. That was the assumption behind one of the strangest contests of the entire Cold War. Not a race to space, a race downward, into the planet itself. The United States went first, and it went for the ocean. Continental crust runs incredibly thick, but the crust beneath the seafloor is a fraction of that. So in 1961, a drilling barge anchored off the coast of Mexico and began Project Mohole, an attempt to punch straight through oceanic crust into the mantle below. It barely got past a couple hundred meters beneath the seabed before costs spiraled, management fell apart, and in 1966, the US Congress killed the funding entirely. The most ambitious geology project of the century died before it really started. This wasn't just a technical failure, it was a warning nobody wanted to hear yet, that the deeper you go, the less any amount of money or engineering seems to matter. The Soviet Union chose the opposite bet, solid ground, thick, stable, ancient continental crust. In 1970, near the border with Norway, a team began drilling into the Kola Peninsula with a target depth of 15 kilometers and 2 decades to get there. On paper, it looked like the safer choice. No waves, no shifting seafloor, no ship fighting to stay in place above a moving target. What they didn't have was any real idea of what they'd meet on the way down. Picture being one of those engineers. You've spent years chasing a single needle-thin hole through nearly 3 billion years of solid rock, some of the oldest continental crust on the entire planet. Down to about 7 kilometers, everything tracks with the models almost perfectly. Then, past 12 kilometers, the instruments start behaving strangely, and nobody can explain why. The models predicted roughly 100 degrees Celsius at that depth. The thermometers read almost 180, nearly double, and that heat wasn't a measurement glitch. It was the first sign that no one had actually understood how the inside of this planet behaves once you touch it directly. At that temperature, crushed under more than 1,000 atmospheres of pressure, granite stops acting like rock. It starts to flow, slow but unstoppable, the way wax softens and slides around a burning candle. Every time a drill bit wore out, pulling the entire column of steel pipe back to the surface took a full day. And during that day, the softened rock oozed back into the freshly cut hole, quietly erasing weeks of progress. Some sections had to be re-drilled 2 or 3 times. It felt, engineers later said, like the planet was refusing, silently, patiently, to let a few humans with steel tubes get any further. The geologists also had a very confident map in their heads of what they'd find. At around 7 kilometers, granite was supposed to give way to dense, dry basalt. That was the accepted model of the era. Instead, the bit crossed that boundary and found more granite. And a little further down, instead of dry, compact rock, it found cracks, fractures packed with hot, salty, mineral-rich fluid, circulating freely more than 11 kilometers underground. A place where, according to every geology textbook of the time, liquid water simply could not exist. The water wasn't the last surprise. Drilling mud started bubbling with hydrogen, as if something far below was breathing. Then, in samples pulled from 6 kilometers down, biologists found something that had no business being there at all. Microscopic fossils, 24 separate species of ancient plankton, sealed inside rock, 2 billion years old. Life had reached far deeper into this planet than anyone had ever imagined, and it had been sitting there since long before humans existed. There was more. Later, far more detailed lab analysis found tiny nanoparticles of gold and silver trapped inside fluid bubbles more than 9 kilometers down. The deepest hole on Earth wasn't just hiding impossible water and ancient life. It was hiding a small, uncollected treasure too, sitting untouched, kilometers below any mining operation on the surface could ever reach. But nothing that came out of that hole traveled further or frightened more people worldwide than something that was neither solid, nor liquid, nor a fossil, a sound. Every new section of pipe released gases nobody had planned for, hydrogen and methane, rising with the water under pressure. One wrong spark, in an atmosphere that saturated with gas, could have turned the entire drilling rig into a fireball in seconds. Crews in helmets and protective gear watched their instruments around the clock, knowing a single failure down there could genuinely cost them their lives. Every new meter was, in the truest sense, a bet. It was in exactly that pressure cooker atmosphere, far from Kola, that a story started to spread that would eventually circle the entire planet. Western newspapers reported that at 12 kilometers down, scientists had lowered an ultra-sensitive microphone into the shaft, and that what it recorded, according to those articles, was screaming. Thousands of human voices rising from the depths of the earth. Tabloids nicknamed it the well to hell. That recording, real or not, got replayed on radio stations and printed in newspapers across the world for years, treated as if it were hard scientific evidence. The real story is much simpler and much more human. No such microphone ever existed. Nobody recorded anything at that depth. The whole thing traces back to a joke published by a Finnish tabloid, later mixed together with audio lifted from a horror film. That small hoax, copied and repeated thousands of times without anyone checking it, ended up looking like serious science. The sensors that genuinely did exist at Kola had a far less dramatic purpose, listening to the drill bit and nearby tectonic movement. But at that depth, sound behaves completely differently than it does on the surface. Rock compressed under enormous pressure turns into a giant resonating chamber. Every crack that opens, every length of pipe that groans, turns into a long, low, almost metallic moan. Witnesses who actually heard it compared it to a wooden ship creaking in a storm, except far deeper and far slower. The project's own drilling chief would later laugh off the well-to-hell legend, but he did admit to something real. In 1995, 5 years after the borehole stopped growing, an unexplained explosion rocked the site. Even he, with all his experience, was never able to fully explain what caused it. Not an urban legend, a documented event nobody has ever fully accounted for. Kola proved something deeply uncomfortable for engineers everywhere. continental crust was a far tougher fortress than anyone had dared imagine, which left one last hope on the table. Under the ocean, according to every available calculation, the crust runs far thinner. And here's the part of this story that gets genuinely unsettling, because that last hope, drilling under the sea, turned out to be an even more brutal trap than Kola ever was. Continental crust averages around 40 kilometers thick, like stacking Everest on top of itself more than 4 times. Oceanic crust, by comparison, thins down to just 5 or 7 kilometers, barely more than an eggshell. On paper, it looked like the obvious shortcut. In practice, it became a completely different kind of nightmare. The first serious attempt, as we already covered, was Project Mohole in the early 60s. Decades later, Japan picked the idea back up, building the Chikyu, a 210-meter scientific drilling vessel with one single goal: reach the mantle through the ocean floor, something no country had ever managed. Picking the right spot isn't simple. Oceanic crust forms hot, right at the mid-ocean ridges, and cools painfully slowly as it spreads outward over millions of years. Drill too close to a ridge, and you hit rock that's still soft at temperatures near 250 degrees Celsius. Engineers need crust that's old, cold, and, even so, still brutally hard. Picture the actual task. You have to lower a drill string several kilometers just to touch the seafloor, then keep drilling solid rock from there. It's like trying to hammer a nail perfectly straight into the ground, except you're holding that hammer from the tip of a fishing rod several kilometers long, and the rod never stops swaying with every wave. Once you're finally down there, oceanic basalt doesn't give up easily either. It's extremely hard and abrasive, chewing through a brand new drill bit in a matter of hours. Every meter drilled on the ocean floor cost weeks of work and staggering amounts of money. One mistake at that depth could mean losing the entire well. The ocean never stops moving. The ship, meanwhile, cannot move at all. A dynamic positioning system corrects the vessel's position thousands of times an hour, so smoothly the crew barely notices. Even that precision isn't always enough. Gas trapped beneath oceanic plates has more than once blown a well out from the inside, sending mud shooting to the surface and knocking out equipment in minutes. Every single one of these problems has to be solved at once, continuously, thousands of meters from the nearest solid ground, with no room for a second attempt if something goes wrong. Which would you have picked? The thick, stable rock of an entire continent, or the thin, far more treacherous crust of an ocean? Humanity, in practice, tried both at once, decades and continents apart, and ran into the same invisible wall either way. That thin oceanic crust turned out to be better protected than anyone expected, arguably even better protected than the thick shield of rock beneath the continents. We have never drilled straight through oceanic crust from the surface of the sea into the mantle beneath it, except, as you're about to see, in one very specific place on the planet, under one very specific set of circumstances. But before we get there, there's a completely different way to attack the depths of this planet, not with a thin steel needle, but with holes so wide they're visible from orbit. So, a thin needle of steel couldn't reach the mantle. Let's try something else. A hole so wide an entire city could sit inside it. Even that, as you're about to see, barely scratches the surface of this planet. In Yakutia, deep in Siberia, sits the Mirny mine, an artificial crater more than 500 meters deep and roughly 1¼ kilometers across, wide enough to swallow whole city blocks. For decades, there's been an official recommendation against flying helicopters over it, and a persistent legend that the air inside can suck aircraft down like an invisible whirlpool. Since the 1950s, Mirny produced enormous volumes of diamonds for the Soviet Union, becoming one of the most productive mines in history. Today, most of the extraction has moved underground, into tunnels beneath the original crater. The real physics behind the legend exists, even if it's far less cinematic than the story suggests. Cold air sinks into a cavity that deep, generating strong downdrafts, and a helicopter can suddenly feel a real loss of lift beneath its rotors. But to this day, there is no confirmed crash directly caused by the phenomenon. Would you fly over that crater? In Yakutia, caution still wins over curiosity year after year. In Utah, the United States is home to Bingham Canyon, the largest and deepest hole ever excavated on the surface of the Earth, over 1 kilometer deep and roughly 4 kilometers wide, wall to wall. From orbit, it's one of the very few human-made structures visible with the naked eye, no zoom required. On April 10, 2013, one entire wall of the mine collapsed in seconds. Somewhere between 65 and 70 million cubic meters of rock thundered down the slope, registering on seismometers like a genuine magnitude 5 earthquake. Enough material to bury all of Central Park under 20 meters of debris. Fortunately, radar monitoring installed at the mine had already detected the wall shifting days earlier. The area was evacuated in time. Not a single person was hurt that day. The slide also crushed some of the largest machinery ever built, 3-story mining trucks buried under tons of rock, and even that hole, the largest ever dug by human hands, barely reaches a bit over 1 kilometer down. The Mantle, remember, starts around 40 kilometers beneath our feet. So why did we stop? It wasn't money, and it wasn't ambition. It was raw physics. With every tool the 21st century has to offer, we still haven't covered even 1/5 of 1% of the distance to the center of our own planet. And here's the most uncomfortable irony in this entire story. Kola's depth record wasn't beaten by any scientific project at all. It was beaten by oil companies chasing profit, first in Qatar in 2008, then on Russia's Sakhalin Island in 2011, with a well drilled in just 60 days. In 2017, another well on that same field stretched past 15 kilometers in total length, more than 18 times the height of the Burj Khalifa, the tallest building on Earth. These wells were never chasing a scientific record. They were reaching oil deposits that would otherwise require entirely new offshore platforms at even greater cost. Here's the twist worth understanding, though. None of these wells actually run straight down toward the planet's center. They curve almost horizontal, kilometer after kilometer, snaking toward specific oil pockets under the seafloor without ever needing an expensive new platform out at sea. Soviet science was chasing an understanding of the whole planet. Modern oil drilling only chases whatever direction makes the most money. In one of these extra-long wells, the drill bit suddenly stopped responding and began spinning the wrong way entirely. The cause turned out to be physical, not mysterious. After kilometers of steel pipe, the metal had wound up so much torque that it was behaving like a giant spring about to release. That same impulse, go just a little further than the last attempt, hasn't disappeared. Right now, somewhere very specific on this planet, someone is still pushing that same race forward. 1 more meter, 1 more day. It rarely makes headlines anymore because it's driven by spreadsheets and profit margins rather than the pursuit of scientific glory. But the engineering behind it is, if anything, even more advanced than what the Soviet team was working with back in the 1970s and 1980s. Even back at Kola, ordinary steel couldn't survive the strain. Engineers had to switch to special lightweight aluminum alloys, and even then, past 12 or 13 kilometers straight down, any material starts failing under its own weight. At this point, it isn't a question of money or ambition. It's a real, measurable physical limit. We'd need materials that don't exist in any lab on Earth today, and cooling systems able to handle over 300 degrees Celsius without a single failure. And now, finally, the fact we promised at the start of this video. In 2023, 66 years after Project Mohole first dreamed of touching the Mantle, An international team drilling in the middle of the Atlantic reached past 1,260 meters below the seafloor at a site called the Atlantis Massif and pulled up the longest continuous section of mantle rock ever recovered in human history. This wasn't a full crust breakthrough, and that distinction matters. What they found was a natural window, a place where tectonic forces had already dragged mantle rock close to the seafloor on their own, right beside a hydrothermal field called Lost City, where hydrogen and methane vent out, rich enough to sustain microscopic life. We have, at last, physically touched the mantle of our own planet. But the original dream, punching straight through an entire crust, start to finish, remains completely untouched, still waiting for someone. We've mapped Mars in staggering detail. We've landed robotic probes on comets, moving tens of thousands of kilometers an hour. And still, on our own planet, under our own feet, we've covered barely a fifth of 1% of the distance to its center. The mantle alone makes up close to 84% of this planet's entire volume, according to the US Geological Survey, and most of it remains, quite literally, an open mystery. We built machines that can survive the vacuum of space, the radiation of deep orbit, and the cold of the outer solar system, and none of them can survive more than a few kilometers straight down into our own backyard. A needle thinner than a dinner plate, and a rock 2 billion years old, just rewrote everything you thought you knew about what's underneath you. If this kind of thing gets your curiosity going, subscribe. The next video covers another limit humanity has tried to cross and lost. And tell me in the comments, if you could send a single probe to only one place, would you choose Mars or the mantle sitting right beneath your feet right now?